Hey, good evening, everyone. Today is March 8th, and this is the TangerineSDR Telecon, and I'm Nathaniel, W2NAF, and I have been very busy with logistics, getting ready for the Hamsci workshop, which is now just over a week away, and it looks like it's actually going to be in person for real. So I'm really excited about that. All right, so next I'll just go down the list here. We have Dave, KD0EAG.
Hello, everyone. I'm turned on. Yes, I haven't been doing anything real exciting. I'm banging my head against little web servers and little chips and LoRa and other ways to get sensor data from remote things without much noise. But it's a long slog. Other than that, not much from me.
Thank you very much. And over to David McGaw, N1HAC.
Hello. Looking forward to the workshop, working on my presentation on our broadband loop antennas. And I thought I'd just kind of point out my little friend over here who's Einstein Tiger. Got it from the Princeton University store. They were advertising it, thought he was cute. Back to net.
I like that, David. Thank you. Over to Jim, K4BSC.
Good evening, all. Well, I'm embarrassed that I have done so little this week. Almost nothing in ham radio. That project I mentioned last week that started out as a 6 to 8 hour project that had gone to 40 and counting is well over 40 and still counting now. And I spent some time this afternoon trying to get back my logbook of the world account, which I had inadvertently let expire about 10 days ago. And that took quite a bit of time, but I think I've got it going now. But as far as productive stuff on this project, unfortunately not. Back to net.
Thank you very much, Jim. Over to Scotty, WA2DFI.
Okay, thank you, Nathaniel, and good evening to everyone. Been a pretty good week here. Not a lot of effort involved, but we got the 2 parts kits double checked for the RF board and the clock module, and the PC boards have been ordered. So we're well along the way to having clock modules and RF modules. So, and I did find a couple of clearance issues with the clock module and both modules, but not serious. Just a few things that the PC board shop didn't like, but yet turned out to be okay. And one of the things they tried to adjust the thickness of the board to adjust the impedances. And since the board has to plug into an edge connector, you can't do that. So that we're going to have to tolerate the impedances. They're a little bit off, maybe 15% off versus 10% off. So that'll be fine because the board is really so small. The distances we're talking about are very insignificant. So anyway, probably will not get boards by Hamsci, but we'll have them, of course, right after Hamsci because that's isn't that Murphy's Law that whenever you put the order in, you get it 2 days after you could have showed it off to everyone. So anyway, back to you, Nathaniel.
Well, we're getting closer. Sounds great, Scotty. Let's see, over to Bill, AB4EJ. And actually, Bill, I saw you spotted on the cluster this weekend. So over to you.
Okay, yeah, I worked DX competition, made about 550 contacts, I guess. 153 different countries. But anyway, so on this project, I've been working on, I've got a nice plotting program for plotting WWV Doppler shift on a grape running GNU radio. We've got 3 people running that now, myself, Aid Monteiro, and Todd Christel. And so we can plot, and it looks like we see a lot of similarities on the, between the different units on for the Tonga event. So that's kind of reassuring that we're getting the same kind of readings in different places. And I've turned my attention now to processing the metadata that comes from the great when running digital RF. I've got the script set up so that it puts in metadata so that it self-documents within the data set what frequency was being monitored and the lat long of the station doing the monitoring. So it took a little bit of effort to figure out how to extract that from the metadata, because the documentation really doesn't tell you how to do it. But fortunately, there was an example. So I was able to get that working just this afternoon. Also, as I mentioned, I've got probably potentially the very last transverter that was shipped out of the Ukraine before everything went in the toilet there. And so I'm playing around a little bit with 2 meters, 2 meter, might set up a station to do some 2 meter contest. And of course, I got to have a good antenna with a mass mounted preamplifier and other things like that. But we'll get there step by step. So anyway, back to Ned.
Thank you very much, Bill. Appreciate it. Let's see, over to Andy, N8LWF.
Hi, guys. I don't have anything much to add, but I do have a question, if I can ask the group. I'm not a professional nerd like most of you guys, so this may seem like a dumb question, but I hope not. I noticed on some of the graphs that were on the Google group, the way you document phase, of course you can't, you don't want to document the negative number, so it wraps around. Can I ask you, like I said, why 180 and why not? Is it because it's relative? Because when it wraps around past -0 on the graph, it comes back to 180, right?
Mm-hmm. Are you talking about the VLF plots?
Yes.
All right.
Sorry about that.
Oh, that's okay. Maybe
I have no problem exposing my ignorance here. So.
Oh no. Maybe we'll go to Jonathan Rizzo, KC3EEY next, and he can maybe answer your question.
Is Andy done?
Yeah, go
so.
ahead.
Oh, okay. I'll give my update, and then I'll answer your question. It's been a busy week, busy weekend for me. I finished up my ham side poster and my ham side poster walk slide. I'm currently working on the presentation. If you have anything for me, Scotty, let me know. I don't really have much to put in there right now. I've been so there has been a new version of the VLF amateur radio synthesizer carrier and modulator synthesizer, EbSynth. Some bugs have been fixed. It's up to a 0.8D. It was at 0.8C. There were some bugs fixed, and it works much better now. It works better with different GPSs, and how it works is that it uses a GPS pulse per second to generate a carrier and phase modulation locked to a GPS reference, and that's how the decoding is done in the noisy environment of the ULF band with all those spherics. Is that the carriers are locked in phase and frequency to a GPS reference, and that's kind of what makes decoding messages exciting. Also, there was an updated version of VLF-RX tools. I think it's 0.9J right now. One of the big improvements is that it's a lot less finicky with pulse per second jitter. So it won't miss pulses. So actually, the issue that I've been having, it probably might fix it, but I need to test it yet. Yeah, there's a lot of good things happening there on the VLF groups. Yes, there was a SID event happened March 2nd. That it was captured on all three transmitters that I monitor, NAA, NLK, and NAU. It's a really nice event. And Andy, you asked about the phase. Now, how it plots the phase is the data is recorded with a GPS pulse per second reference, and it uses that to determine the phase. Now, which plot in particular did you have a question about?
I was looking at the phase plots exactly. And that's part of the question also, is that unless you know, unless you have a really accurate clock and you know the propagation factor between the transmitter and you, the absolute phase of that signal is going to be really hard to catch. And that's part of the question too, is that's because instead of looking for, when you're talking about some variations this small, I imagine you're looking for, the first thing you look for is phase variations if you're looking for a Doppler shift, because that's how it manifests itself, right?
I think what we'll do, I'd like to keep going with the lists for now, and then we can come back to this during the open discussion.
It wouldn't bother me if I let it drop either, because it's just curiosity.
Okay. Yeah, and you can also keep chatting with the text chat too. We'll go through the rest of updates and we can bring it up an open discussion. So thank you. And next we have Dave Larson, KV0S.
Well, I'm sorry I'm late. I got lost track of time, and thanks to Dave Witten, KD0EAG, he sent me a message and alerted me that I missed the start of the session. So thank you, Dave. This week I've been working on actually spending some time relearning Docker and trying to build some simple projects. So that's about it for me. Back to net.
Thank you very much. And let's see, over to Bill, N8ET.
Don't have too much to report on space weather, but I was going to get on the contest this weekend and decided that I was going to get the voice recorder going, and that went real quick. And then I decided that I'll work the rotor into the N1MM. So I pulled out an old rotor controller that I got sort of half working, and it's all on breadboard. I've got it sort of half working again to the point where I need to put it in a box. And now I'm trying to 3D print a box, but I haven't figured out how to lay the box out, but I haven't figured out how to put the bottom in it. I make the hole through the thing, through a cube, but I can't get the bottom to come back. So I'm sort of stumped on that. I've been working on that the last 10 or 12 hours. So maybe next week I'll have something. Back to you.
Thank you very much, Bill. Let's see, over to Bob, N4HY.
It took me forever to find the mute button. Sorry, it's been a while since I've done Zoom on my phone. I'm out of my shack. I got the Flex 6700 and the power amplifier and the Maestro control panel all hooked up to my multi-band dipole, and my Yagis are together and gonna go up on the roof. So I've been busy with ham radio here of late. And I'm working on the Red Pitaya sounder code so that we can just talk to it with GNU Radio or other things. So that should be interesting. And I jumped back into it after Nathaniel introduced me to his ham today, who had an application. And the application is they want to use NVIS for MCOM and other things. And this is a reasonably inexpensive way to sound the ionosphere with gear that basically anybody can carry with them. It'll cost like $400 or $500, but for MCOM, that's in the noise compared to a lot of stuff. So anyway, I'm back busy doing ham radio and happy to be here.
Thanks, Bob. That's great. Let's go to Dan N4XWE.
Thank you, Nathaniel, and good evening all. Not a lot going on. I've been doing some work with scripts, which is kind of a weekly occurrence. There are always a few upgrades here and there. I found out a couple of weeks ago that my daughter and son-in-law are moving to Huntsville, Alabama. So I have a couple of tasks to do while I'm there, having to do with investigating places to live. So that came as a little bit of a surprise. They actually visited there about 3 weeks ago and liked it enough to move. They currently live in Northern Virginia, just on the outskirts of DC. Anyway, that's about it from here. Back to you, Nathaniel.
Thank you very much, Dan. That sounds great. And over to Gary, AF8A.
Yeah, good evening, everyone. I've been playing with a couple of things this week. Kind of dipped my toe into the FMT and time nuts world a little bit, trying to understand the frequency, accuracy, and stability characteristics of my low band rig using WSJT. So that was an interesting exercise, but I'm ready to set that aside. And I've also been playing down in the workshop a little bit, building my first surface mount QRP rig. So hopefully this is good skills. It'll set me up for fiddling around with more things to come with HamSci. Back to net.
That sounds great, Gary. Over to Howen, KD2MCR.
Hi, good evening, everyone. I guess this is my first time since I got back from Alaska. I was there about 10 days. I'm missing all the beautiful aurora and missing all the nice rocket launch that just happened. I was there to install rheometer, but while I was there, it was pretty cloudy and geomagnetic activity was pretty low. But that just one day before I arrived, one of the colleagues who is actually expert in auroral observation said that was the most beautiful aurora that he ever seen. So I missed the best part. And then after I installed rheometer, rocket was launched. So if you allow me to share some my screen, that would be great.
Sure.
So there was also a citizen science component of this project. So this project is called LAMP, LAMP, laws through. Let's see, laws through. Do you see my browser?
Yes. Mm-hmm.
Laws through auroral microburst pulsations, called LAMP, involving NASA, University of Iowa, University of New Hampshire, Dartmouth, Air Force Academy, JAXA, Japanese, bunch of Japanese colleagues too, Nagoya University, Tohoku University, etc. I was involved in this project unofficially because the rheometer ground support wasn't originally planned in the original proposal, but they realized that it is highly necessary. So I was added like in the last minute. So anyways, so what I was gonna tell you is that the LAMP mission, there is also a citizen science component. One of the guys from Montana, I forget, he called himself a auroral chaser. He always look for nice aurora, and then he actually kind of tagged along this the project to take pictures and nice images of aurora. So he just posted the rocket launch into the aurora, so you can see the very nice pulsating aurora. And you can see the development of auroral patches and everything. In about 2 minutes or so, you will see the rocket launch soon. So this is the rocket launch. Rocket is over here.
There it is. Hit your shutter. Sorry, they didn't count that down.
Then you can see the second stage blow up. Second stage. So I was at one of the
You saw a rocket.
Native American reservation called Vinetai, which is quite small town. Population about, I don't know, 150. The reason why I went there is because that's actually ground magnetic field footprint of the apogee of the rocket, so that we can measure signatures directly under that magnetic field field of the rocket apogee. So that's how I spend my time there. The rheometer, you can see basically that's where's the picture of the rheometer that I installed with the help of an engineer from Pennsylvania. This is the antenna. Basically, this is designed in a way that the antenna beam pattern is as isotropic as possible, so that it can, measure the background noise of the radio signal coming from the universe. So then during auroral activity, the signal is supposed to be attenuated because it's actually measuring the noise background from the universe. So this is one of the example during substorm. I believe black trace comes from Dawson, Canada, and then red one came from Pocofly Research Range from the rheometer that we installed. So you can see the good correspondence between the two signals, showing sudden drop in background noise during relatively high substorm activity. So this can be very useful to understand how auroral activity can interact with particles, especially for this project. The interest is people are interested in measuring electron precipitation and interaction due to certain type of wave activity in space called chorus, which they believe that associated with this type of pulsating aurora. So this is the main objectives. And the other picture that I want to show is, this is the picture of the sounding rocket. This is where the payload is located, and all the thrust part is actually all covered with styrofoam because they are very sensitive to the external temperature, so they are covered. So I was lucky enough to see this. Of course, Dave McGod has been working on this rocket project many times, so she should know much more about that. But this is my first time to see the rocket facility for the first time. Then the other cool thing about this project, one of the instruments has a camera that was developed by University of New Hampshire facing downward. So when they fly, the camera was able to take images of the aurora from above. But one technical difficulty is that since the rocket spins about 1 revolution per second, so the camera platform has to despin at the same rate, the other way, counter spin, so that it can stabilize the image. So from my understanding, this is their first time to take stabilized image after a lot of failures. So we should be able to get some images taken from the rocket, looking downward during the aurora activity. So yeah, I'm very happy to see the data coming in, so that there can be a lot of exciting stuff to do. So that's all. Back to Nat.
Thanks, Yeoman. That sounds very exciting.
Cool.
That was great.
Yep.
Let's see. Now I have to remember where I was on the list here. We'll go to James. Where your call sign go? KG4DSG.
Good evening, Dave and group. Not much here. I'll just kick it back to the net.
Great. Over to JWB8SBI.
I am here. Good evening, everybody. Not a whole heck of a lot to report from up here, getting ready for that 600-mile 2-day drive down to Huntsville, and of course the return trip. Very much looking forward to seeing everybody there. Also, just by way of, since you were talking about holidays earlier, starting from sundown Wednesday to sundown Thursday is the Jewish holiday of Purim, when we also have holiday pastries called Homen, which are filled with sweets, with fruit filling pastries filled with various fruits, things like that. So because it's a joyous holiday. And where was that launch site? I didn't miss that. Howen, where was that rocket launched from? I didn't catch it.
Is about 30 miles away from Fairbanks, Alaska, called Poco Flat Research Range.
Okay.
Yep.
So it was basically, and how far up did that rocket go?
Depends on the payload, but no, yeah, depends on the launch vehicle. But I think this goes up to, say, I don't know, like 5 kilometers, 500 kilometers above the ground.
Okay.
One anecdotal story, actually, which I forgot. We were worried that this rocket launch may be canceled because of the Russian invasion. There was actually a very well-known incident that happened in 1992-ish. I don't remember, but that could give some wrong signal to Russia, because if that was launched from Alaska, last time, 1992, the rocket launched from Norway, and since this is kind of close to Russia, it could give. So I think that back then Russia almost reacted militarily. So
right,
we were very concerned about that. But since this particular rocket was designed to fly only within Alaska, and it wasn't really heading west, so it was only heading north. So we are basically, the NASA told us that it is okay. So it wasn't canceled. So.
Right. I'm familiar with the incident you're talking about, and we can get into it, but it was actually because one Russian officer manning the radar stations decided this isn't a real attack. So he delayed reporting it. And that's why we didn't go to nuclear war.
Yeah.
Anyway, that's another story there. Looking forward to meeting everybody and seeing everybody down there in Huntsville. And just for general information, the holiday of Purim runs from sundown Wednesday to sundown Thursday. During that roughly 26 hour period, that's the holiday. 7-3 to everybody, and be reading the mail on you. Back to net control.
Thank you, Jay, and I hope you have a good Purim. Let's see. Next we have Joe, W7LUX.
Good evening, everyone. I've been dealing with winter weather here, and freeway closures and all sorts of little details, and also helping Janice with her Morse code class that she's conducting for the local club. Anyway, that's pretty much it. Back to you, Nathaniel.
Thank you very much. And over to Jules, K2, KGJ.
Good evening, Nat, Nathaniel. Not a lot this week. Spent most of the week doing some support activity for my son's sugar bush control system. A few other odds and ends in the ham radio operations. And just a reminder to everyone who may be in ARES or maybe associated with ARES that there's a recent Mars symposium that just reminded everyone that RACES, the Radio Amateur Civil Emergency Service, is actually the only thing that's officially recognized in FCC rules regarding an amateur radio emergency service. That's codified in the FCC rules, whereas ARES is not, interestingly enough. Anyway, back to Net.
Thank you very much, Jules. I appreciate that. And let's see, and over to Michael Howen.
Good evening, everybody. This week I've been involved in catching up to about a point 10 years ago. So getting a HPSDR radio up and running and learning how to do that. And I've been digging into some new GNU radio and Spectrum Lab and some things like that. So that's what I've been working on. Back to Nick.
Thanks, Michael. And last, but certainly not least, if his microphone's working, I'm not sure if it is Mike Neruda, AA8K. I know he's been having some, he says, sorry, still no video or audio. All right, well, that concludes the call up here. So I guess we'll go to open general session and take it away.
A couple of quick ones. One thing for everyone, a reminder is I believe next week we're going to be on daylight time. Well, all of you are. I'm not going to be, and Joe is not going to be. But so it'll be for a lot of people, it'll be an hour earlier, the meeting, because it still remains at 9 p.m. Eastern time, correct?
Mm-hmm.
So
yes.
It'll be the same for everyone else, I guess. But for us in Arizona, it moves from 7 to 6.
Oh, don't we stay at 9 p.m. EST, Eastern time, no matter what it is?
Right, but it'll be 9 p.m. Eastern Daylight Time, which will be okay for everyone else. But for us here in Arizona who do not switch, it's going to be an hour different. So anyone else who doesn't.
For you, it's different. For us, it's the same.
Correct.
California is going to join us shortly.
All right, so we won't be the odd man out. And the other thing I forgot to mention was we're actually gearing up to build magnetometers. We haven't actually had the official vote on the TAPR board yet, but it looks like the TAPR is going to approve the money necessary to build 250 kits. So as soon as the last part becomes available, which is scheduled for May 2nd, keep all of your fingers crossed, we get that part, we will have boards, again, probably 2 days after Hamvention, but we'll probably be selling them at Hamvention because they'll be pretty much built by then. So assuming we do get the parts on May 2nd. So we're getting the rest of the parts kitted, ready to be kitted up. As soon as the TAPR vote goes in and says go, we will be ordering all the parts and then waiting for that last one. So because the board's ready to go. In fact, we likely will order the PCBs so that we'll be ready to build as soon as the last part comes in.
That will be great. And we don't know when the last part will
buy a magnetometer kit. Now we have to work on the garden end with the PVC pipe.
Yeah.
Yeah,
Were you gonna say something, Jules?
No, I was just going to second Scotty's comments on that. Really good to see that come along.
Been a long road, huh?
Amen.
Mm-hmm. Go ahead, David.
Yeah, a couple of things. First, the Norwegian rocket incident was in 1995. It was the same type rocket that probably was just launched from Poker. I've been involved with the launch of a number of those, including from Norway, and we always check with Russian air control to make sure that everybody knows it's going off. And that time at that time, the nuclear forces were in fact put on alert. So it's considered one of the closest incidents to actual nuclear incident. Actually, I had a question for Howen on the rheometer, because we actually used to have rheometers up at Poker. We had 4 single frequency and a broadband. We had taken the single frequency ones down. They were out in the field next to the Science Center, which I think is where you have that one now. And then I don't know if the log periodic that we had set up way in the back of the field, that might still be there for all I know. But we had one there at one time. It's been since dismantled. Guess he's walked away.
Sometimes it takes a minute to find your unmute button.
Right. I'll ask him another time.
That sounds good. And just another reminder, if you are planning on going to the Hamsci workshop in person, you need to register today if you haven't done that already. Or maybe tomorrow. But
I paid my money.
Yep. I'm working on making up name tags. I have some Python code I wrote for the 2018 Hamsci workshop that puts on the Hamsci banner on the bottom and puts little color codes for whether you're registered for Friday, Saturday, and the banquet. And now we're adding the reception too. So working on getting that code running again.
Did Andy get his questions answered?
I'm not sure, but now is a great time to go back to that discussion.
Well, I thank you for asking. And now it's probably a great time for everybody. So yeah, I'm done. Because this may sound like a dumb question. And yeah, I did. I think I did. And the question is, of course, you don't wrap around phase on the graph. When it hits -0, it's going to go wrap around, because what you're interested in is kind of a relative phase. You're looking for the Doppler shift of the waveform as it comes in, right? I mean, you don't need the exact phase that it, or are you? That's what I'm asking. Are you tracking the phase from the transmitter? How, I imagine the transmitter of the signal has to be not only extremely accurate, but you have to know the accuracy of the transmitter, right?
Well, what we're comparing it to is a GPS time reference. That's where we're getting that information from. We don't know the accuracy of the transmitter or anything like that. So that phase is in comparison to a GPS time reference. And what it's doing, I mentioned this in the chat. It's just changing in phase from 0 to 180 back to 0, you know, throughout the day. But it uses a GPS time reference to as a starting point.
Fascinating.
Yeah, but you are just you're receiving the phase as you know, at your antenna. You're not really referring to the phase at the transmitter. For one thing, they don't tell you that. It's a military transmitter. It also is, it's 2 frequencies that's being shifted between plus 50 hertz, minus 50 hertz from, say, the 24 kilohertz of NAA.
So it's modulated.
Yes, it is modulated. This is for communicating to submarines. And you can, it may have an absolute phase reference, but we don't make use of that.
Yeah, that's, you're just
but
using
but the carrier frequency is atomic. locked.
Yeah, I would imagine that's going to be pretty stable. Well, that's fortunate because in your measurements of Doppler shift, you're going to have, it strikes me that that's not a significant thing. It's, in other words, a small thing to measure, right? On a
Well,
scale.
you get a large shift from like just day to night as the ionosphere, the Earth's waveguide changes height. You get a very distinct phase, even when you're relatively near to the transmitter. We in New Hampshire here often monitor that station. And even though we're almost in its near field, it does change significantly. But, you know, the wavelength is almost 8 miles.
That's
But
amazing.
you're still not so close to the transmitter that you're looking at absolute phase.
Yeah. That explains a lot. I appreciate it.
Yeah, in fact, just as an aside on that, we recently had a rocket launch from Wallops, Virginia, which is where they're built and also can be launched. And we were actually picking up NAA and other stations from the rocket using the amplitude and phase to probe the ionosphere as we fly up above it.
You know, something else I thought of while I was listening, I'm going to go to work tomorrow and I'm going to be really thankful that nothing I do is going to bother a single Russian.
Yes. Yeah, well, some of us are rocket scientists, so we have to worry about things like that.
Yeah. Well, mad respect, man.
Jonathan, do you want to talk a little bit about the observations you made this week?
Yes, so I monitored three Navy transmitters, NAA, NAU, and NLK. I would monitor more, but the monitoring program uses up a lot of CPU, and it would get the Raspberry Pi really hot. It's running on a Raspberry Pi, so I only monitored those three, and the more MSK stations that you monitor, the more CPU time that it uses. But that was a sudden ionospheric disturbance, little past 1730 UT, and it was such a nice capture because I was able to see it on all three of those transmitters. So, and I put this in my poster, and I explain a little background. But solar flares, you know, when a solar flare occurs, it'll ionize the D and E layer of the daytime side, and in VLF that causes an enhancement in propagation, which is why you saw that jump in amplitude. In HF, it usually causes a diminishing. So what I did was I checked the GOES data, and there was a nice peak at that time that corresponds to those amplitude, those shark fins that someone was referring to on the group. They matched up perfectly. So that that capture did correspond to an actual solar flare. You could also detect gamma ray bursts because they do the same thing. They're a little bit harder to find. You've got to compare the data, but that was a really nice capture, and I put that in my poster. So I check every day to see if I find anything, whistlers or chorus or SIDS like that. So that was a really nice surprise to get that. So I was really happy about that.
Well, there's a newcomer to the group. When I saw the, that's quite something to be, for a newcomer to see. That's a lot of work, and it looks really cool. And it certainly caught my attention for a very long time. So thank you.
Oh, thank you. Yeah. Yeah, if you go to the HamSci or if you attend HamSci, whether virtually or in person, you will have access to my poster, and it gives there's a couple paragraphs talking about that event, and I also have to reply to some of the emails too, so watch out for those as well. And the hope is we could detect a lot more with the system.
Well, with any luck, I'll be able to join you guys and get one of these things built.
If you would like to get started, there are look at software called VLFRX tools. I will put a link to it in the chat. That is the software tool set that I use. Basically, what you do is you would either build or construct a VLF receiver, and you would connect that to a PC sound card or a Raspberry Pi sound card, and you would run the software with a GPS receiver, and you can capture the VLF spectrum, which will monitor multiple VLF transmitters, natural radio signals like whistlers and chorus. You could do analysis on spherics. You could do there's many different things. So I will put the link in the chat just so you could kind of skim through the different things you could do with it. It's a little it could be a little daunting at first. It's kind of geared toward advanced users, but once you kind of go through it, it makes more sense. So I'm going to get that link now.
Well, I think I'm kind of, at least I got to start. I have built a what was called at the time the VLF-1, which is a VLF radio, and I stuck it in a little box and works really well.
That would be one of the receivers that you would use for this.
I'm trying to find a link for that because it was so long ago. I don't even know if the info for that particular radio is online still.
They have a newer version out. It's called the VLF-3.
Yeah.
If you look
Yeah, I
on,
saw that. It's got some really nice advancements on the radio I've got that mine doesn't have.
yeah, because I have both the VLF3 and the VLF2, which another name for that is the RS4. Both are, you know, very effective E-field receivers, and they could be used portable out in the field if you want to listen far away from power lines, or they could be used at home if you're you know, in a rural area. With some audio transformers, you could set it up so it could feed into your PC sound card, and it could and with the software, it'll automatically monitor for these different kinds of events. And with the software, it'll filter out the power line hum, and you could also listen to a stream just like you would if you were listening in the field.
Well, that's fantastic. I will say this about the VLF-1 too, is that it does a really good job of picking up aircraft communications. If they're flying overhead, I can hear everything there, even though it's just VLF. And I'm sure that's just because, you know, it's picking up stuff it shouldn't. But
what does it sound like? Because I never really. I live right by an airport, and I was never able to pick anything up.
it sounds crystal clear. I mean, it's just natural, clear, broadband voice.
So it's actually demodulating the signal
Perfectly.
because
It's
VLF,
actually pretty impressive.
because from a VLF receiver, some of the receivers, because of the front ends, act as a diode detector, and it could actually demodulate medium wave transmissions. And I guess it could do the same thing for aircraft. I haven't really heard any AM on any of my receivers. So this just sounds like voice, clear voice.
Oh yeah, clear voice. I can show you a schematic of it here, I think. If I can get the image to load. Yes, I can. May I share my screen?
Yeah.
Mm-hmm.
Let me find out what the heck icon it is to click on. There it is. You should be seeing a schematic.
Oh, that's the VBB4.
There you go. I knew I was talking to the right guy. But yeah, well, that's, wait a minute, there's more in this folder. You know what I did when I built this radio? I probably copied a lot of schematics.
So what station is that picking up?
It's picking up aircraft overhead. Anybody that flies overhead, I can hear their conversations perfectly.
But they're not on VLF.
No, that's why I brought it up, because I was kind of surprised the first time I heard it.
Oh yeah. Well, yeah, aircraft use AM. So any kind of rectifier detector will demodulate it, but yeah, you shouldn't be picking that up. It should be, I mean, they're up in the 100 megahertz range.
Exactly.
Are you also hearing spherics as well?
I am not. I do hear, I've heard I suppose you call them the sprites. I've heard plenty of sprites in the atmosphere, but I've never heard the dawn chorus.
I think what you're referring to, sprites, you mean spherics. Those are the clicks and pops that you hear.
Yeah, the pings and
Well,
yeah.
pings are called tweaks.
Tweaks. There you go.
A if there's a higher frequency, like if it kind of sounds like a squeaking sound, that's called a tweak, and they come out at night. They're a product. Those are spherics that have traveled tens of thousands of miles and had some of their frequencies dispersed
Right.
along the one of the resonant modes of the Earth ionosphere waveguide, and the fundamental is 1.7 kilohertz. So that's usually what you hear. You could they sometimes they could go up to up to eight they could go up to 8 different frequencies, but usually it's at 1.7 kilohertz. So yeah, there's there's static, there's the spherics that you hear, there's tweaks. Dawn chorus and whistlers is kind of rare. That's why the software, it'll automatically find it in the stream and it'll record it without you actually having to be out. But that's kind of amazing that you're able to hear voice through it. That's really crazy. But it's not unheard of that medium wave stations can actually come through as a voice. On the VLF2, there's a ferrite bead on the gate of the JFET input, and that acts as a choke to choke out any of the high frequency components, like medium wave and aircraft. That's pretty cool.
Ferrite bead wouldn't do that, but it should filter out the VHF that is aircraft communications.
Yeah.
But if you have a strong AM station nearby, it wouldn't filter that out. But there should be filtering at the front end anyway. Something is overloading.
I still can't find that schematic. Oh, well.
You're pretty close to Columbus Airport, so the aircraft going overhead wouldn't be very far overhead. They'd be real loud.
Yep. Yeah, even if I go down to the park here.
So they only transmit a few watts. Not like you got a 10 kilowatt station next door.
Yeah, but if it's only 1,000 feet over you, boy, instead line us up loud.
I mean, I have to filter out AM stations all the time that are a couple miles away at a kilowatt or more.
Well,
I got to tell you, speaking of filtering out AM radio stations, I hope you don't mind. I got to spend a moment and tell you about a story that happened to me outside of WLW. I had a customer with a telephone in a shack that was like 300 feet from the fence around WLW. And WLW came through his phone so loud, I'm surprised the phone wasn't smoking. We had to put in a 8-foot ground rod for this phone so it would shut up. Okay, back to net.
Yeah, when you're that close to a station, you put up a long wire and rectify it and power your house off of it.
Wasn't it WLO in New Orleans that used the fountain outside their transmitting site as the water cooling system for their transmitter? I seem to remember that. It was a New Orleans 50,000 watt clear channel station. I think it was WLO. Maybe I got the wrong call letters.
It was WLW, I believe. They actually
WLW.
had they actually had a fountain on, I think the fountain is still there.
Yeah, anyway, they
Hey
put
kids, this
cooling
fountain is warm.
yeah.
Well, you have to wonder what they used for cooling the 500 kilowatt station that existed at one time.
Yeah.
I
What
think
was
that
that?
was Chicago or Indiana or
That
somewhere
was
around there.
WLW. I used to take school from, one of my professors was an engineer who worked at WLW and later in life worked on the geosynchronous satellite. And he said there were times when they were running 500,000 watts that lightning would hit and it would cause a constant permanent arc between the tower and the fence. And he said it was the most beautiful thing you ever heard in your life because it was a real infinite baffle. It had the whole sky as a baffle. And I can't even begin to imagine what that sounded like.
We had a local broadcast station here in Flagstaff many years ago, and they had mounted a 2-meter, not 2-meter, 150 megahertz commercial antenna up on the transmit tower, and the doggone thing was arcing, and it put out a bodacious bunch of RFI all around 2 meters and the VHF 150 megahertz band. Finally, I went down and said, "Hey guys, we got a problem here," and we figured it out. But heck, the meters on the transmitter were all dancing in synchronization with a little WWV time cube I took down there to illustrate the problem. And the guy looked at it and says, "Oh." Oh boy, I've been after him, and I even had written the FCC because I didn't get any results. And so they were desperate to solve the problem and just didn't know how or didn't know where to look. Went out and shook one of the guy wires for the antenna, and boy, the little radio receiver went totally bananas. Didn't take the engineer too long to figure out what the raw problem was after that.
Yeah, and you are correct. WLW of Cincinnati is the only station that has had an authorization for 500 kilowatts back in the 1930s. Yeah, Crosley put that together. Interesting. Just to tell you what 500 kilowatts can do, I was installing a system up in at Sonderstrom in Greenland, and it was a broadband receiving up to 10 megahertz. And I was looking at it right after installing it, and I was getting like 0.7 volts out of the to the receiver at 6 megahertz exactly. And I'm saying, what in the station would be running at 6 megahertz? Well, it turns out I was able to tune it in on a shortwave receiver, demodulate it, figure out that it was coming from Havana. It was 500 kilowatt station coming out of Havana, Cuba.
Yeah, 6 megahertz is one of their main frequencies.
Right.
Well, that's what you call signal strength, huh?
So
Yeah.
you were getting like 1.5 or 700 millivolts out of your antenna at 6 megahertz. That's
Not out of the antenna, but out of the antenna and preamp. And I wasn't expecting anything that strong. That's kind of very close to our maximum input. And this was just, coming all the way up from Cuba. And to be on at 6 megahertz exactly, that was very surprising. But you're right, that is one of their frequencies that they sit on.
odd enough, 6 and 6.06.
Right.
Not sure why they have two frequencies that close, but they must have different beam patterns for the antennas. Or maybe the transmitters are located in different places. So does anybody know if the shortwave transmitter, like up in Sackville, is still on the air up in northeastern Canada? It used to be a big shortwave broadcast site with a bunch of transmitters on it.
Yeah, don't know.
Yeah, I guess internet will help me find that out.
I will say that there's some very interesting antennas just south of the rocket range on Andoya in Norway. Clearly, they're big wire log periodics pointed in various directions. Of course, you're not supposed to know about those.
We didn't hear you say it.
I'm just saying that they're military installations of some sort.
She told us she'd have to kill us, right?
Something like that. I'm open to bribes.
Yeah.
I'm starting to yawn.
Yeah, I think it's time to QRT here. We're over our time limit a little bit, so.
Yep, I agree. I think I'm about ready to check out for the night.
Oh, one thing, one parting thought is check records of the last few days because we've had some pretty good geomagnetic activity. We were up to K of 5 for quite a while.
Going to be a good summer.
Yeah, it should be.
There wasn't any chorus on the receiver, but there was just that one SID. But I'll check to see if there are more.
All right.
73, everybody. See you next week.
73, everyone.
73.
73.
73.